Alright, today's topic is 13-1, Arithmetic and Geometric Sequences. Today's date is today. Our objective is to identify an arithmetic or geometric sequence and find a formula for its nth term. Let's first talk about what an arithmetic sequence means. The difference between two consecutive terms is constant. What that means is you add or subtract the same amount each time. So on this one, you're going up by 4 each time. You have to check and make sure it's the same amount each time. If one of those wasn't a 4, then we would say it was not arithmetic. But all of those are 4, so my common difference is positive 4. On the next one, I'm going down by 7 each time. In that case, my common difference is negative 7. On our last example, going from my first to my second term, I'm increasing it by d. Going from the second to the third, I'm adding another d. I went from a plus d to a plus 2d. And going from the second to the third, I increase that by another d. Geometric sequence. That is when the ratio of any two consecutive terms is constant. What that means is you're multiplying by the same amount every single time. So on this first one, I'm multiplying by 3 every single time. So the way that we would write that then is your common ratio is 3. On this one, I'm actually dividing by 2. Dividing by negative 2. Dividing by negative 2 is the same as multiplying by negative 1/2. So my ratio there is negative 1/2. On our last example, going from a to r, I multiplied that by r. From AR to AR squared, multiplied it by another R. So my common ratio there is just R. Just to get some terminology, if you see T sub 1, that means that it's your first term. T sub 2 is your second term. T sub 3 is your third term. T sub n would be whatever term there is, your nth term. Depending on what your n is, that's where the placement would be. So on this example, they give us an equation and they're asking us to find the first 4 terms. So I would just take 1 squared plus 1, get 2. 2 squared plus 1 to get 5. 3 squared plus 1 to get 10. And 4 squared plus 1 to get 17. If you look at the sequence here, 2, 5, 10, 17, this one is not arithmetic and it's not geometric. There's a pattern, but it's a neither. So on these examples, if we wanted to find the first 4 terms, all you're going to do is plug in 2 times 1 plus 3, 5, 2 times 2 plus 3, 7, 2 times 3 plus 3 is 9, 2 times 4 plus 3 is 11. This one would be arithmetic. I am going up by 2 each time. Again, just plug in -2 to the first, -2 squared, -2 cubed, and -2 to the fourth. This one would be geometric, because what I'm really doing is I'm multiplying by -2 each time. And on our last example, 3 minus 7 times 1 would be -4. 3 minus 7 times 2 would be 3 minus 14, which would be -11. 3 minus 7 times 3, that'd be 3 minus 21, which would be -18. And 3 minus 7 times 4, which would be 3 minus 28, which would be -25. Here, it is going to be arithmetic. And my common difference is -7. If you notice, that's kind of like the slope. That's how much it's changing every single time. I meant to point out these are two formulas that you're going to want to have almost memorized. You're going to be using them quite a bit. The first one you always use for arithmetic sequences. The second one is for geometric. Pretty much if you know the first term or the first number in a sequence and what the common difference or the common ratio is, we can make an equation. Let's go ahead and do that. The first thing that I always want to ask myself, is it arithmetic or is it geometric? Well, this one is arithmetic, and my common difference is 3. My first term is 1, so I'm going to start by just writing down the formula. T sub n equals T sub 1 plus n minus 1 times b. Go ahead, plug in what you know. First term is 1. N is our variable, and d is 3. I'm going to go ahead and neaten that up a little, and I get -2 plus 3n. On the next example, I notice that one is geometric. My common ratio, or what I'm doing is I'm dividing by -2, which is the same as multiplying by -1/2. So I want to make sure I use the correct formula, use the one that's got an R in it. Let's go ahead and just plug in what we know. T sub 1 is 24. R is -1/2. And that's going to be n minus 1. Well, on this one, I'm going to kind of think back to some of the rules that I have for exponents. That's actually 24 times -1/2 to the n times -1/2 to the -1. Remember, if you have the same base, you're really adding your exponents, so I'm just kind of separating those out. -1 or -1/2 to the -1. Would be -1 to the -1 over 2 to the -1, which we don't like negative exponents. We're going to flip that. 2 over -1 which is -2. So we can make that equation look a little bit neater. Take that 24 times -2 and you get -48 times -1/2 to the n. In the honors class, they're going to be a lot more picky about simplifying it as far as you can go. If you get to this point, chances are you're going to be okay. On this one, I want to go ahead and find an equation. The key word here is arithmetic. So I automatically know which formula I'm going to use. My t sub 1 is 15. So I'm actually just going to erase that and put in 15. N is my variable, but D, I don't know what D is. But they tell me the first two terms, so I can figure that out. Going from 15 to 21, my D is 6. So let's go ahead and erase that D and put 6 in its place. I'm not going to simplify this any further because they don't ask for the equation, they just want to know what t sub 20 is. That'll be 20 minus 1 times 6. So then it becomes just calculator work. 20 minus 1 times 6 is 129. And that's it. Let's do one that is geometric. Oops, I think I skipped one that I wanted to do. I did. On this one, they tell us the third and the fifth. So what I'm going to do is I'm actually going to write down what I know. I don't know the first, don't know the second, I know the third, I don't know the fourth, I know the fifth. And the one thing I know about arithmetic is you're adding the same amount each time. So going from the third to the fourth, I increased it by D. From the fourth to the fifth, I increased it by D. So 8 plus 2D would equal 14. If you solve for D, you get that D is 3. So 8 plus 3 would be 11. 11 plus 3 is 14. That works out. I'm just going to kind of work backwards here. Subtract 3. So now I know the first term and I know my common difference. So it's just going to be a matter of putting everything into that formula. And I'm going to just kind of substitute everything in at one time. T to the 50 would be your first term. Your n would be 50. And your D is 3. And that just becomes calculator work. I think that works out to 149. All right, let's do one more example. On this one, we want to find the indicated term of each geometric sequence. Well, they're telling us T2, so we don't know T1. T2 is 64. We don't know T3, T4, and T5 is -8. So I know I'm multiplying by the same amount each time. So there I'm multiplying by an R. There I'm multiplying by an R. So 64 multiplied by that R 3 times would equal -8. Divide by 64, and I get R cubed equals negative 1/8. Take the cube root of both sides, and you get r is negative 1/2. So I'm going to look at my formula. T sub n equals T sub 1 times r to the n minus 1, and we are looking for T sub 9. So let's go ahead and substitute everything in. T sub 9 would be your first term. Oh, we haven't found our first term yet. Well, if I'm multiplying everything by negative 1/2, that would be negative 32. That would be negative positive 16. And that would be negative 128. So I do know my first term now. It's negative 128. My r is negative 1/2. And that would be 9 minus 1. If you work everything out there, you're going to get negative 1/2. All right. Hope you enjoyed the video.